All right, so we're going to talk about the sum and difference identities. Now consider a sum means addition and difference means subtraction. So that's why these are called sum and difference, is because you're adding or subtracting something from another thing. I guess I'll explain it better in the video in a little bit. So right now I have two equations all right here in this one big thing. I can split it up by taking this and this right here. So what I mean by that is if I have sine and I do alpha plus beta, so I do the top part of that, that's going to equal sine alpha cosine beta plus, because I'm doing the top part there, cosine alpha sine beta. Now, if I do the bottom part right here, so that means I have sine alpha minus beta, that's going to equal sine alpha cosine beta minus cosine alpha sine beta, because this is subtraction on the bottom, okay? Likewise, I have the cosine one right here, so if I take the top operation, so if I'm adding, so if I go cosine alpha plus beta, that means I have cosine alpha, cosine beta, and the top thing here is a subtraction, so it's minus sine alpha sine beta. Likewise, on the bottom here, I have subtraction, so it's going to be cosine alpha minus beta equals cosine alpha cosine beta plus, because that's what's on the bottom here, sine alpha sine beta. Okay? So those are your four equations. You don't have to worry about memorizing them. Those are just for sine and cosine. We'll have different ones for tangent. Those will be in a different video. But you don't have to memorize these. These will be provided for you at any point in time. Okay? So in order to actually use these, what these are asking is, say for example, I'm asking you to find the exact value of cosine 15 degrees. If you were to take a calculator and put it in a calculator, it would get you a decimal back. But I want the exact value. Just like the exact value of the cosine of pi over 4 is square root 2 over 2. I want something exact like that. So here's what I'm going to have to do is I'm going to have to look at my unit circle. And on my unit circle, I'm going to have to find two things that I can add together or subtract one from the other to equal 15. So I could do 45 minus 30. I could do 60 minus 45. I could do 135 minus 120, 150 minus 135, 225 minus 210, 240 minus 225, 315 minus 300, or 330 minus 315. All of those will get me 15 degrees because there is a difference, sum and difference, there's a difference of 15 between them. So I'm just going to be basic and say that we'll do this as cosine 45 minus 30. So that means that I'm going to be using this equation right here because you see I have cosine, so I need the cosine, and I have something minus something, so something minus something. So I'm going to be using this equation. I know I put it as 45 minus 30 because this has to match this number right here. It has to match that 15. I can't do 30 minus 45 because that would be negative 15. I can't do 45 plus 30 because that would be 75. I can't do 30 plus 45 because that would also be 75. This is the only way I can do it with these two numbers. So now I'm going to use this equation, and instead here I have alpha here and I have beta here, because if I look right here, that's what that's telling me. So I'm going to use this equation, and everywhere I see alpha, I'm going to put 45, and everywhere I see beta, I'm going to put 30. So I have cosine 45 cosine 30 plus sine 45 sine 30. So now from there, that's when I'm going to look at my unit circle. So this is saying cosine 45. Well, the cosine at 45 is right here at square root 2 over 2, because remember, x is cosine, y is sine. So this is saying cosine 45 is square root 2 over 2. So here I've got square root 2 over 2 times cosine 30. So at 30, cosine is square root 3 over 2. So square root 3 over 2. Sine at 45, that's square root 2 over 2 right here. So I've got square root 2 over 2. And sine of 30. Right here, sine of 30 is 1/2. So I have 1/2. So now that I've actually gotten rid of all of the trig functions in here and replaced them with numbers, now I'm just going to have to do the math. Now I can't take this and plug this into my calculator because square root 2 times square root 3 is going to give me a decimal. And remember, I need this to be exact. So I have to remember my methods for actually multiplying radicals. In this case, I have square root 2 times square root 3. That's going to get me square root 6. Because square root a times square root b equals square root a times b. Whereas square root a plus square root b equals just that, square root a plus square root b. Can't change that. Okay, so now 2 times 3 is 6, so I've got that. 2 times 2 is 4. Square root 2 times 1 is going to get me square root 2. 2 times 2 is going to get me 4. I almost said 2. And then I go ahead and just combine these because just like I said right here, when I'm adding them together, I can't change that, but I just need to go ahead and put them over the same denominator to kind of make it look clean. So now I have square root 6 plus square root 2 over 4. That right there is my final answer. That is exact for cosine of 15. Now you could take this and you could enter this whole thing into your calculator, square root 6 plus square root 2, and then divide the whole answer by 4. And whatever you get, when you enter in cosine 15, as long as your calculator is in degrees mode, it will match that. All right, let's try a different one. Let's do sine of negative 105 degrees. So again, that's where I'm going to have to take something on my unit circle and figure out what I'm going to do there. So I could do 120 minus 225. That'll get me negative 105. So that's what I will do. So I have sine 120 minus 225. I could use something else if it also adds up to be negative 105, but this is the one that I'm choosing to use right now. So I'm going to take this information and I'm going to put it into the equation right here because I have sine 120 minus 225. So because I'm using sine and I'm subtracting the 2 degree measures to get the final answer, this is the equation that I'm going to use. Oops, I need to scroll. So here, I'm going to do sine 120 cosine 225 minus cosine 120 sine 225. All right. So now I'm going to look at my unit circle. At 120 degrees, sine is square root 3 over 2. So square root 3 over 2. Cosine 225, that's going to give me negative square root 2 over 2 times negative square root 2 over 2. Cosine at 120 is going to be negative 1/2. Negative 1/2 times sine at 225 is going to be negative square root 2 over 2. Negative square root 2 over 2. So again, just like on the last one, I just need to do the math where I need to multiply these two fractions together. So I have square root 3 times negative square root 2. So that's going to get me negative square root 6. 2 times 2 is 4. I'm bringing down that subtraction sign. Negative 1 times negative square root 2. So I have a negative times a negative. So that makes that positive. So I'm going to have square root 2 over 4. So I'm just going to combine those together as negative square root 6 minus square root 2 divided by 4. Okay, and there is my final answer. All right, now what if I gave you something like cosine 5 pi over 12? Well, the easiest way, not the only way, but the easiest way is to go ahead and convert that into degrees. Now we remember to convert from radians to degrees. We have to multiply by 180 over pi. If we were going from degrees to radians, we would multiply by pi over 180. So right now, that's going to cancel out these pi's, if I could draw a straight line. And now I have 5 times 180 divided by 12, and that gets me 75. So I'm doing the cosine of 75. All right, that's not too bad. So let me go ahead and figure out what two things on my unit circle can I add together or subtract one from the other and get 75. Well, I can do 30 plus 45. That's nice and easy. So I'll do cosine 30 plus 45. This is my alpha, and this is my beta. Now, it is important that I go ahead and write out this next step where I do cosine 30, cosine 45, minus sine 30, sine 45. Sometimes you might get comfortable and just look at the equation and put the number in. Like if you were to sit here and just look at this equation and just go ahead and just enter your number in by looking at your unit circle, you'll probably make a mistake. I don't suggest doing that. I suggest writing this step out and then substituting your information in. So now here I'm going to go to my unit circle, cosine 30. So at 30, cosine is square root 3 over 2. Square root 3 over 2. Cosine at 45 is square root 2 over 2 times square root 2 over 2 minus sine at 30 is 1/2. And sine at 45 is also square root 2 over 2. So square root 2 over 2. When I multiply all of these together, I'm going to get square root 3 times square root 2 gets me square root 6. 2 times 2 is 4. 1 times square root 2 is square root 2. 2 times 2 is 4. So now I have square root 6 minus square root 2 over 4. And there's my final answer. It's really not hard. It's just more or less plug and chug. The biggest thing you have to do is worry about your subtractions. A lot of mistakes are made when you are using with the minus signs right here, or even if you had like a negative somewhere in here, dropping a negative somewhere. Those are the simple mistakes. That's going to change everything. Now, if you notice right here, I have square root 6, I have square root 2, and I have 4. Right here, I have negative square root 6, negative square root 2, and a 4. And here I have square root 6, square root 2, and a 4. So there's always a square root 6, there's always a square root 2, and there's always a 4. That's going to happen every single time because what you've got right here, if you look, if I was to take pi over 6, let's just use 30, and I was to add 60, I'm going to get 90. If I was to take 30 and I'd subtract 60, I'm going to get down here at negative 30, which is equal to 330. 30 and 60 will always get me something that is already on my unit circle. I'm always going to end up not using both of those. You will always use something on your 45, so 45, 135, 225, or 315. You'll always use one of those, and then it's going to be a difference between if you're using the 30s, your things that are divided by 6 here, your radians divided by 6, so 30, 150, 210, 330, or your 60, 120, 240, and 300. It's just going to be one or the other. It's never going to be the 30 and 60, 120, 150, 210, 240, 300, and 330 all at the same time. There's always going to be one of the 45s involved. And then if you look at these numbers, if I'm doing sine and cosine of each one of these things, there's always a square root 3, there's always a square root 2, and they're all divided by 2's. So I'm always going to get a square root 3, a square root 2, multiplied together somehow to get me a square root 6. I'm always going to have a square root 2 multiplied by a 1, and then I'm always going to have a 2 times 2, so it's always going to get me a 4. So if you get anything different besides a positive or negative square root 6, positive or negative square root 2, or positive or negative 4, you've done something wrong, and you need to go back. Okay? So that's all I'm going to say in terms of sine and cosine, doing the sum and differences. I'm going to have another video for tangent of doing sum and differences.